Most of you probably already know about the laws of physics governing the universe that you and I reside in, but what if I told you there was another subatomic world where the lines between reality and fiction become blurred? Hi, I'm Carl, and today I'm going to take us on a brief 3-minute journey into the magical, mystical world of quantum mechanics. Suppose we have two twin cats. Let's call this one Schrödinger, and this one, I don't have any more quantum mechanics jokes, so we'll just name him Catty McCatface? Let's give each of these kitties an opposite spin. Note that this does not work with real cats, so please don't try this at home. I doubt any house cat would be pleased with being spun in any direction. Now, we put each cat in a separate box and mix up the boxes until we don't know which cat is in which. If I then mail one of the boxes to my evil twin in the Balkans, with a note telling him the rules of this scenario, and he looks inside the box to find Schrödinger, who is spinning up, he knows with 100% certainty that the cat in my box is spinning down. For some reason, subatomic particles also behave in this manner. This phenomenon is known as quantum entanglement, and the interesting thing about it is that it is not limited by the distance between the two cats, or particles. They could be on opposite sides of the universe, but if you know the spin of one, you know the spin of the other. But what happens if my evil twin never opens the box I sent him? Is the cat inside spin up or spin down? Well, the answer proposed by quantum mechanics is that the cat actually exists in both states at once, and it only chooses which one it wants to exist in when the box is opened. This is exactly the same for subatomic particles like electrons and neutrinos, and the way this works is via something called quantum superposition. In fact, quantum mechanics also states that the cat, or particle, chooses to spin completely randomly, and that its entangled partner somehow gets this information faster than the speed of light, making a certain German physicist very upset indeed. One of the most infamous dives into the world of quantum mechanics was a little something called the double slit experiment. This involved shooting electrons, one at a time, randomly at a screen with two slits in it. The hypothesis was that since electrons are distinct units of matter, two lines would be expected on the backboard where the electrons passed through the slit and hit it. However, this is not what happened. The pattern the electrons formed was in fact an interference pattern caused not by particles, but by waves. Here's where things get weirder. Physicists wanted to know why the electrons seemed to behave as a wave rather than a particle. So they put a detector in front of the slits to see what was going on. And the electrons stop behaving like particles now. You think that's crazy? Well, this is quantum mechanics, so you know things are about to get even crazier. Physicists decided to put the detector behind the slits, thinking that this would force the electron to behave like a wave again. What actually happened was that the electron still behaved like a particle. What this means is that the electron passed through the slit as a wave, and then when it was detected, forced its past self to behave like a particle so that it could come through the slit as a particle. An event in the present affected something in the past. The truth is, no one really knows why subatomic particles behave the way they do. But hey, maybe you've been inspired to go out and discover that. If this video did its job right, that is. I'm Carl, and you've been watching Quantum Mechanics Explained with Cats.